Hey, what's up guys, my name is Cherno, welcome back to another Hazel devlog. So last week, I'll put up a video right there. Yes, week. I'm actually so excited I've managed to make 2 devlogs in 2 weeks. But anyway, last time we talked about how I was having a bunch of Vulkan issues, basically. So the driver would crash, Vulkan wouldn't really give me much information. I tried debugging it, I couldn't really get anywhere. Validation layers were giving me nothing and all of that. And today, I'm here to tell you that everything's working. So the first thing that I want to do is thank all of you and all of your suggestions. To be honest, when I explained the problem in the devlog, I didn't really expect as much helpful information as I got. I mean, not only were there tons of comments suggesting that I do this or that, I also got emails and, you know, various other messages on other platforms being like, hey, have you heard of this? Have you tried that? And by following your advice, I solved my problem. And today I'm going to show you how that happened. And the key is a little something called Nvidia Aftermath. So I hadn't actually heard of this before. And again, this is thanks to you guys that, I mean, you know, this is why it's so great to share your development with the world, right? You get all these helpful resources and feedback from the community. But basically what Nvidia Aftermath is, Nvidia Insight Aftermath, I guess they're calling it. It's a simple library that you integrate into DirectX 12 or Vulkan's game crash reporter to generate GPU mini dumps when basically a crash occurs, right? So what you can do is you basically download this library. Anyone can do this, right? You have to sign up for like an Nvidia developer account, but that's like totally free and it's pretty straightforward. This is completely free. The license is pretty permissive as well. So in other words, you can actually ship this with your game or with your app if you want to, so that you can get kind of feedback from like client crashes in like a distribution environment as well, not just for debugging, which is great. But basically, whenever you get like a crash in your GPU, and Aftermath will actually dump all of the details of that crash to a file, and then you can open it in with Nvidia Insight, which is like a graphics debugging tool, and actually see what's up. So that's exactly what I did. Okay, so just a little side note as I'm editing this. I didn't mention this in the video, but Nvidia Aftermath only works on Nvidia GPUs, just in case that's a surprise. So a few days ago, basically like 2 days after I put up that video and I read all of your suggestions, I had 2 issues actually with Vulkan that I knew would cause like a device lost error and thus would crash the driver. And what happens is I set up the Nvidia GPU. Okay, actually, no, I need to show you guys what I actually did. So there's this GitHub repository, an Insight Aftermath samples, which basically has like a DirectX 12 and a Vulkan example. And it's pretty cool. There's all these files, but there's the main file, I think, which actually has the, well, it's this one, VK Hello Insight Aftermath. This actually has the usage of this little library they've written that uses the Aftermath library, which is like the Aftermath GPU crash tracker. So in other words, this actually enables Aftermath and, you know, hooks up their little GPU crash tracker, which is over here. And then you like hook it up before you create like the Vulkan device, basically. So I looked at this example, and this example actually features like a Vulkan device lost crash. You can actually see it happening over here. What is it? Device lost, error device lost. So if error device lost happens in their example, they just sleep for 3 seconds to make sure that the asynchronous, you know, file writing has time to actually finish before like you exit in this case. But whatever. The point is that they've got a really nice sample. And that's one of the things that I love about NVIDIA's libraries is that they generally have pretty good samples. So this is what I based it off of, and I basically grabbed these files, I chucked them into Hazel, I hooked up the GPU crash tracker in much the same way, and then what happened is when I got a device lost, it dumped out 2 files to disk. So we're going to be using this one as an example. I've got a bunch in this repository. It also dumped out a shader file. And so what these are is one of them is just a GPU dump file, which if you open up Insight, so we'll open up Insight here, which you can also download for free. We can just drag this in. And as long as you've got your shader paths hooked up correctly, so what this shader kind of hash file is actually like a debug file for the shader itself. So Aftermath can do a whole bunch. This isn't really a video about Aftermath. This is more like a post-mortem kind of crash, you know, situation, I guess. It's a devlog, right? If you guys want me to actually put together a proper Nsight Aftermath like tutorial or whatever, let me know. But this is more just kind of my experience in a bit of more of a high level view. But basically this shader, shader file contains like, my understanding is it's got like the debug kind of symbols of the actual shader itself. I'm not sure if you might actually, I don't think it has the source code. I think you have to hook that up as well, and I'll show you how in a minute. But basically this has information about where exactly in the, like what the shader was doing. All of the invocations of like the fragment shader, for example, what was happening at the time of the crash, which is really cool. And I'll actually show you that here. So if you go Tools Options, it's a bit weird that this is global, but under Search Paths, right, you can actually set this up, because you can see at the moment, I think, I've got it in a few different situations here. Yeah, so see, for example, shader object file not found, right? And the reason that that happened is because I haven't hooked up my search paths correctly. So for example, for the driver shader output paths, instead of this, which is like a different branch, I guess, of Hazel, we can hook in, let's change this to just be editor workflow, which is the dump we opened. That's a branch. And if I select that and hit OK, then you can see now it's actually saying assets shader skybox.glsl, and if I double click on it, I actually get source code, and it actually tells me the exact line that was being executed when this like happened, which is really cool. Now, I will say though that if you're looking at this being like, how is the open bracket crashing this? You have to remember that the source code, like in Hazel, for example, and the source code in your engine potentially as well, might not align correctly. So this is clearly a fragment shader, right? And we know that it's line 18 that caused the issue. But if you look at this, this is actually like a Hazel shader, which has type vertex, type fragment. So both shaders are in one file. There's comments before that. So we know that the text that is actually sent to like, SPIR-V to compile everything is this for the vertex shader and this for the fragment shader. So really what's going on is it's saying line 18 of this text. So clearly it's not that, and I can't, if I open up like VS Code or something, and I paste this in, and there might be like a space or something, so like I always give or take a line, but basically this is kind of what we're left with if we just paste that text in as it is. And you can see that line 18 is that, it's probably not that, it's probably this. Right? So we know that the line that seems to have crashed is this texture access, which if we actually read the crash, I kind of went forward into the shader, but if you look at what actually happened in the dump info, we can see that it was a page fault, right? Which is like a memory access problem. And then in the crash info, you can see that there's some page fault going on. Here's the address. Here's the address of like this resource that is trying to access, which is what actually caused the issue. The size we can see here is 512 megabytes, width, height 2048, depth 6, MIP levels 12. So we have information about the texture itself that it's trying to read. We know that obviously it's some kind of resource access that was a problem. And if you look at the GPU state, you can even see that it was in fact texture. And that the texture access faulted. Everything else seems good, busy or idle, right? That's fine. But something went wrong with like texture operations, right? And this is the actual texture. So this actually by itself, before you even hook up that shader source code, has so much interesting information that, I mean, I can immediately identify that texture. It's clearly going to be a cube map, right? The depth is 6. It's got 6 faces, 6 layers. MIP levels 12. Well, the MIP levels 12 correspond with like the width and height. So I know it's a 2048 by 2048 cube map, right? There are only 2 of those. No, there's only 1 of those actually in the engine, and that's like the environment map, right? So clearly accessing the environment map is problematic, and why it looks like in the skybox shader when it actually tries to draw the the background, I guess, it's failing because it can't read the texture. So that immediately showed me one of the problems that I had, which was, and this is like, as I said, I had 2 issues with Vulkan, just, error, device lost. One was somewhat weird and happening on random devices, and we'll get to that in a minute. But then there was this one which was like 100% reproducible. And basically what this ended up being was, instead of, what I was doing is I was deleting my old environment map. So if I played with like my little Preetham Sky model, or if I tried to load, It's great. If I tried to load like another cube map or something like that, I was deleting the old one, but I wasn't submitting the deletion of that memory and that image view and all the other things into the render command queue. So I was just doing it immediately. So as soon as the reference count hits 0, and we are kind of left with, you know, a texture or a resource that has no references, thus should be deleted, I was immediately calling those Vulkan delete functions. And I guess what happened was this fragment shader was either in flight or about to be rendered or whatever. And I guess it had already passed validation, and it had been like, everything's fine, and now we're going to render it. Oh, wait. It's been deleted, I can't access that memory anymore, or whatever. And it was just giving me like a device loss with absolutely no validation or anything like that. So what I did was I just submitted it to the render command queue like it should have been done, and that means that it happens after like the render operation takes place and everything's done. And that fixed it. So that was the first issue. The second issue, which was the more serious one in my opinion, because this one was somewhat new and it was reproducible. Reproducible is always good, not reproducible is always bad. So the second one happened on some devices, and that should have been a hint now in retrospect, because now that I know why, it makes sense. So it probably means that I need to pay more attention and be a better detective or something. But basically, what would happen is, on my computer, very rarely, when I loaded a cube map, like an environment map, the way that happens in Hazel, I described that a little bit in the last devlog, but basically we load like an equirectangular image, we filter it, and then we generate like an irradiance map from that as well. And we generate like all the LODs, all the MIP levels and everything. And so basically we run like 3 different compute shaders to make all of that happen. And I had been really like, you know, I'd been really safe with that. Like, I knew that like potentially maybe, you know, synchronization issues could cause that. Usually, in my experience, synchronization issues. So in other words, if you don't finish writing to a compute shader, if your compute shader is writing to a texture and you don't finish that operation before you start rendering that texture in a fragment shader, usually that doesn't really cause like a crash or a device thing. It just means like your data is missing, or like you might see flickering, you know, stuff like that. Usually it's not like a hard crash, at least in my experience. But anyway, so just to be super safe, I put fences everywhere. Okay, so I think taking a look at it is probably gonna make more sense. But basically what I did is when I submitted my actual like compute shader to the compute like command queue in Vulkan, I'd made sure basically that after I do that, there's this fence that we wait for after the submission. So nothing else happens. The CPU literally just waits here for however long that compute shader takes, and then it continues. So that means literally nothing else could possibly happen while we wait for this, unless like some other stuff has been previously submitted to the queue, but it wouldn't, because like in C++ land, when we submit things, we do the cube map first, obviously, because you've just decided you want to load it. There can't possibly be already a submission to render the new one before you've... Anyway, so basically what that also means conveniently is that we can time this, right? Easily. We can just create like a CPU timer and just see how long this takes. Because once you submit something to a queue, if you wait for the fence to complete, if you wait for the, you know, for everything to finish, then you also know how long it takes, which is nice. So I was also able to see, I guess, how long this execution took. And I mean, I looked at it and it didn't seem like it was too bad. Like it, you know, for one of the shaders, it was like a few milliseconds. For another one, it was like half a second. And then like the irradiance one took like 2 seconds, 2.2 seconds, something like that. And I was like, okay, sure, whatever. 2.2 seconds, you know, a little bit of time, but you know, we're filtering this cube map. We're trying to make it pretty. This is like a loading operation. It's not a per frame operation, obviously. So whatever. But then one thing that I noticed was happening is that, again, as I mentioned, on this computer, which isn't like, it's a 1080 Ti. It's not the best card you can get these days, but it's a pretty strong card. It was the fastest on this, and I couldn't get the crash to happen very often. On my laptop, which is hooked up to that monitor in the background, that's got an RTX 2060, but it's a mobile chip because it's a laptop, and it was happening way more frequently. Not every time, but maybe like when I hit F5 to run Hazelnut and I was loading a cube map, you know, which I just had to do on startup, it would happen like 1 every 5 times, 1 every 10 times, something like that. But then for other people on the Hazel team, like Peter, notably, he was getting this every single time, which was crazy. I was like, what? Like this, you can't load any cube maps. What's going on? And he has the weakest card. He's got a 750 Ti, which I think he says it took like 4 seconds or 5 seconds, or I don't know. It was way slower. And I was like, okay, that's interesting. So, but I didn't realize that at the time. Maybe I should have been like, on lower tier hardware, it seems to be crashing more often. Up to the point where it just crashes every single time. But I didn't notice that. Until Nvidia Aftermath, again, to the rescue. I set it up on that laptop because, again, on here it happened so infrequently that it was like, whatever. And I got some pretty interesting results. And so this is the dump from the laptop, which I just copied. So let's take a look at this one. I'm not going to bother hooking up the shader because the problem is actually pretty visible here. So, and here's the thing, right? Like when I first saw this, it took me a little bit of time here. When I first saw this, I was like, there is so little information here, but it's kind of almost like a less is more situation. Not really, but like my point, I wouldn't be opposed to more information. But the thing is, this amount of information was enough for me to figure out what was going on, right? In both cases. It's like deceptively little amount of information. It looks like it's not much information, but there's actually a lot of stuff here, and especially once you hook up the shaders and everything as well. But basically, you can see this is like from Thursday last week. This is what happened. So device state is hung, right? To contrast this with the other one, right? The device state was a page fault, right? Okay, whatever. Memory access bad. You know, we can maybe take a look at this. But this state was literally hung and in the compute channel, it seems, right? That's all that we really have here. And then in the crash info, again, if we were to hook up the shader, we can see kind of all the different invocations of the compute shader, which of course is kind of running in parallel, and you can actually see like what it's executing. I hooked that up on the laptop. It wasn't that useful. It was just random points in the compute shader basically. And you can see that over here, you know, we have all of these like pipelines being busy, whatever. And if you do hook this up, as I mentioned, you would see where you were in the shader. But none of that is really that interesting. We know which shader it is. So again, I didn't copy the shader object file, but if I open it on that computer, I can see that it's the environment irradiance.glsl shader, right? So it literally says, kind of like what we had here with the shader location being an actual file, right? It also had that there. So I knew which compute shader was causing the problem. Which was coincidentally the one that takes the longest. So as I mentioned, like over 2 seconds on this computer, like 4 or 5 seconds for Peter or whatever it was, right? And device state was hung. So what seems to be happening is that that compute shader is taking so much time that the driver is like, something's not right. Which, I mean, like 2-3 seconds or even 5 seconds for a compute shader, I would not have thought that would have been too much. Like maybe 30 seconds, a minute, whatever. I expect people are doing some kind of compute operations on their GPUs that are taking a long time. Why is this, you know, why is it suddenly like, 2 seconds? 3 seconds? You did not just say 3 seconds. I'm abort mission, crash the driver. I don't know why, right? But what I do know is that I lowered the quality of the environment irradiance map, the compute shader. So basically, lowered the number of samples. As I saw, as I showed, we were doing like 2048 by 2048 for the rest of the cube maps. Lowered that to like 1024 because it's usually good enough, right? Most of this stuff is just being used for like reflections and, you know, 2048 is pretty overkill. I just like to, you know, turn stuff up to like 11 and just see what's up. But 2048 is admittedly quite a lot. You saw it was taking 512 megabytes of VRAM. I mean, it's uncompressed data and everything, but 512 megabytes of VRAM for a single cube map is quite a bit, right? So whatever, you know, let's turn that down. We turned Peter's down significantly, down to like, I think we were doing a quarter of the irradiance samples, which is just basically how much it samples. So therefore, you lower the samples, obviously the compute shader is going to be way faster. And we lowered it to like 1024 for the size, and he never got a crash again. So long story short, if you take too long in your compute shader, you will lose the device. I did not know this. I didn't really didn't really find that out from my research. I even asked like friends of mine from EA, have you seen this before? No. So I don't know. I don't know how common this is. I'm not sure if it's something. I think someone on my Discord mentioned something about like you can change this in the registry or something so that it will maybe wait 10 seconds or whatever before being like, okay, I'm aborting the whole thing. But that was my experience. Let me know what you guys, if you guys have faced similar problems, I guess, before. Huge thank you like to you guys, honestly, for helping me, for putting me onto the right track for solving this. Because I feel like if I had not seen this, you don't expect something to be like, oh, it's taking too long, crash. That's not usually something. It just takes long. That's what I'm used to. But we can see here that literally the device state is hung. And by reducing that time, by reducing like the complexity, I guess, or how much time the compute shader takes, that problem went away. And I don't have it anymore on my laptop. Peter doesn't have it anymore, which is great. And so now what I have is like a little. Actually, let me show you guys. This is a bit of a Hazel devlog. I should probably show Hazel, right? But basically now what's happening is I've merged everything back into the master branch. I still have this up. I can probably get rid of this. It's still here. But inside the settings over here, there's some renderer settings, and you can actually change the environment map size and the number of samples. It's actually like 64 times this, but it's the number of samples that you can run on the compute shader if you wanted to, beef it up or whatever. So we have some drop downs there so that people can kind of configure this based on the power of their graphics card. But apart from that, stuff works pretty well. This is Vulkan. As I mentioned, this is release. Let's just load something for fun. We have this old kind of game, which is missing its environment map. But, we can quickly just like generate, a nice looking environment. I love this little dynamic sky thing. It's pretty cool. And we can just hit play, and there you go. That's obviously hooked up to like C# scripting, and we're using Box Studio for physics in this example. It's changing like the material settings from the C# as well dynamically. That's why this goes red if there's a collision, and everything is basically working in Hazel as expected. So that's kind of where we're at, I guess. And this is all inside Dev Master. Oh, sorry, this is Dev Master. I've just got the folder named that. It's all inside the master branch, inside Hazel Dev. So if you guys do have access to that, then feel free to check it out. Let me know if it's stable on your computer, because my goal obviously is to get the master branch as stable as possible. If you don't have access to Hazel Dev and you want to get access to everything you saw here and help support the development of Hazel, then you can go to patreon.com/thecherno and you'll get access to all of the latest source code that we work on. There's like a few active branches because there's some great people from the community helping out as well. And we've even got some plans for some like demo games to show off Hazel and what it's capable of, because we're moving through this pretty quickly. So anyway, thank you as always for your support. I hope you enjoyed this devlog, and I will see you later. Goodbye.